Hello, welcome back to Weathering, Erosion, and Deposition. This is part 2, Erosion and Deposition, and our aim today is to describe the processes that cause erosion and deposition. So what is erosion? So in our last notes we discussed what the weathering is, and weathering was the breakdown of rocks. Erosion is when those weathered pieces are moved from one place to another. So the method of how they are moved is called erosion. So an erosional system, so for erosion to happen, you need to have an agent of erosion, which means something doing the moving. You need to have sediment that's being moved and the driving force, which is gravity. So there's 5 agents of erosion, 5 things that cause sediment to move. The first one is gravity, second is the wind, third is running water, fourth are waves, and fifth are glaciers. And we'll be referring to these as our 5 agents of erosion, which I call our 3 W's and 2 G's. Wind, water, and waves, 3 W's. And the 2 G's are glaciers and gravity. That helps you remember. The number 1 agent of erosion that does the most moving of sediment is running water. And that makes sense since water is covering the majority of the earth. So it does most of the moving of sediment. Okay, so we've talked about weathering, which is the breakdown of rock, erosion, which is the moving of the sediment, and last but not least is deposition, which is when these pieces stop moving and are deposited. So it's the process by which sediments drop out of the water, wind, or ice carrying it. So when they drop off, they stop moving. So where does most deposition usually occur? It usually occurs into large bodies of water. Typically you have lots of streams, running water, carrying sediments along, and it ends up in a larger body of water where it stops moving and drops off and settles to the bottom. So what causes deposition? Why does deposition occur? Deposition occurs when the velocity or speed of whatever's carrying the sediment stops or decreases. So as soon as that water, wind, waves slows down or stops moving, everything it's carrying will also stop moving. So we have some graphing relationships that typically come along with this unit. So let's talk about some of these. How does a change in velocity affect the rate of deposition? So as the rate of deposition increases, what happens to the velocity? So as a stream slows down, the deposition increases. So velocity decreases as the rate of deposition increases. And that would be an indirect relationship. As size of the sediment increases, what do you think happens to the rate of deposition? So what's going to settle fastest as a stream is flowing and slows down? Will larger pieces settle first or smaller pieces? So larger pieces will settle faster than smaller ones. The larger pieces need faster moving agents of erosion. So as it slows down, the larger pieces will settle out first. So as size of the sediment increases, the rate of deposition also increases, and this would give us a direct relationship. How about roundness? As sediment gets rounder, so if you go from a flatter piece of sediment to a rounder piece of sediment, which one's going to settle to the bottom faster? So as it gets rounder, from this to this, it's going to deposit faster. So as roundness increases, rate of deposition also increases. The flatter one will kind of, do one of these as it floats down and take a little longer to get to the bottom. So the shape, the rounder the particle, the greater the rate of deposition. So that's a direct relationship. So how about density? How would that affect the rate of deposition? So as your piece of sediment gets more dense, is it going to settle faster or slower than one that's less dense? So as the sediment gets more dense, the rate of deposition will also increase, so this gives us a direct relationship. The next question is about the degree of saturation. So saturation is how full the water is, or how, like a sponge, how full it is. As it gets more saturated, it's more full. So the degree of saturation affecting the rate of deposition. So if you have water that is full of a mineral, like say salt is dissolved into it, the more saturated it is with the mineral, like salt. So if you add more salt after it's already saturated, more minerals will then deposit or settle out. So once the water's saturated, it can't hold any more, so more of it will precipitate to the bottom, as this is showing. What are sorted sediments? So we have two types of sediments, sorted and unsorted. And sorted would be when the sediments are similar in size, shape, or density. So the pieces are going to look similar to each other. So unsorted sediments is when you have a mixture of pieces together. So you don't have them sorted by all the same or similar. You have a mixture of small, medium, large, different shapes, different densities. So how does a gradual change in speed of wind or water affect how the sediment is deposited? So if you have the mouth of a river, which is where it enters a larger body of water, if this river slowly slows down, what will happen to how the sediment's deposited? So when velocity slowly decreases, okay, gradually decreases, which means the stream flows from a steeper area to a flatter area over time, not too quickly, the larger, rounder, and more dense sediments will settle out first. So you'll end up with horizontal layers coming outward from the mouth of the river to the larger body of water. So this picture also shows this. You'd have the river ending right here, and now the bottom of the river this is going into like the lake. Okay, so the river has entered a lake or a larger body of water, maybe an ocean, and the larger pieces are going to settle first, and it'll get smaller and smaller until you have the much smaller pieces as you go further out. So horizontal sorting looks like this. So this is different than if you end up with a drop-off like they had in Nemo. So in certain parts of the bottom of the ocean, all of a sudden you have like a big cliff. Okay, and this also happens on land. You might have a cliff where water is flowing like a waterfall. So if there's all kinds of sediment in that water that's coming up to the waterfall where it drops, then what will happen if you dump off the sediment from one spot, landing in one spot? What's going to settle to the bottom? How will it settle? So in this case, when you have a mixture of sediments falling quickly, it settles in vertical layers. So you end up with the largest, roundest, and most dense at the bottom, and the smallest, flattest, and least dense on top. And that looks like this. Okay, so you end up with these different events of quick deposition. And we find this in the rock record. You could see that here we have two different events where sediment was deposited really quickly into two layers on top of each other. And this completes this part 2 of the notes. See you next time.